Good morning. Welcome to second session in module 5 of computer networks. Today's topic is ARP and RARP. As you already know that ARP and RARP is part of internet control protocols. First we look into ARP and then we look into RARP. So what is meant by ARP? ARP stands for Address Resolution Protocol. Before getting into know more about ARP, let's see what is meant by ARP or Address Resolution Protocol. So suppose we already know that we usually two machines to connect. Suppose we have two machines A and B which are connected to the same network. What if A wants to send an IP packet or a packet to B? In such case, A must know not only the IP address, but also know the B's data link address. So what is meant by data link layer MAC address? It's just nothing but Ethernet address of the B. So if A wants to communicate with B, let me write down. If A wants to communicate with B, A should know, A should be having its own IP address, and I was writing E as a MAC address or Ethernet address. So A should have its IP address and the IP address. A should also know the B's IP address and Ethernet address. So the address resolution problem deals with the mapping internet address. Internet address is the IP address to the physical address. So what are the cases in which we used to have this address resolution protocol? So as we already know that each and every Ethernet card or Ethernet device or the computer will be having its own unique Ethernet address or MAC address. So if we change the Ethernet card, then automatically the physical address or the Ethernet address will also change. And each and every Ethernet address is 6 bytes long, so it's not possible to send across the network saying that the Ethernet address has been changed. So also if new machines are added to the network, then also we need to know that what is the new Ethernet address of the particular system. So this is the address resolution protocol. In order to deal with the address resolution protocol, we came with the address resolution protocol. So what is meant by address resolution protocol? The address resolution protocol is a protocol that allows host to dynamically map. You should understand, that allows host to dynamically map internet address to the physical address. So let me explain with the help of an example. So we have A, we have B, we have C, and we have D. So A, B, C, D. These are the four hosts inside a particular network, inside a local network. So in the case of ARP, address resolution protocol, ARP sends an ARP request frame using the Ethernets. Ethernet means Ethernet cards broadcast capability. So while you already know the broadcast capability, broadcasting means that sending a message across all the machines inside a network. So what happens? A will send a message which is known as the ARP request frame. Send an ARP request frame to all the routers inside, all the hosts inside the network. All the hosts inside the network. So it will reach C, B, and B. So what is there inside that particular request frame? This is the next question. So it will ask, A will ask, what is the Ethernet address of the internet? Suppose A wants to communicate with B, and A is having the internet address of B. I already know the internet address. For example, the internet address of A is 10.1.2.2, and internet address of B is 10.1.2.7. A also know its own Ethernet address, but A doesn't know the corresponding uh, Ethernet address of the B. It's only A only knows the IP address of B. So A will send an ARP request frame, which what all things will be inside this ARP request frame. It will have the IP address of A, its Ethernet address, and also the internet address of B. But it doesn't know the so it will ask for the it will send a message asking that I do have the IP address of B, but I do not have the uh, Ethernet address. So please let me know what's the Ethernet address. So this message, this IARP request frame will first come to C, then it will again go to D, and when it reaches B, B will know that B already know that its IP address is 10.1.2.7, which is being asked by A. So it will what it will do? It will populate. It will upload the corresponding Ethernet address of B to this packet. The packet, this frame packet, which is being sent by A, and send it back to A. This is the working of in A address resolution protocol. So let me explain again. The ARP request asks what is the Ethernet of the internet address A.B.C. A.B. This is not just an internet address. So A is having an internet address 10.1.2. A wants to communicate with B. A only knows the IP address of B but doesn't know the internet address. So it will send an ARP frame request asking for the Ethernet address. So each and every machine receives the copy of this frame, and the machine having the desired IP address. So in this case, B is having the desired IP address will respond with the Ethernet address. Of course, machine doesn't send out the API each time. So one question which arises that every time if A wants to communicate with B or C or D, should A needs to send this ARP request frame? No. So it is a one-time purpose. For example, in this case, A will send this packet frame. C and D doesn't have the Ethernet address of B, so C and D will forward it to B. B is having the Ethernet address, and so B will encapsulate this Ethernet address in this reply frame. So what B will do, like since A wants to communicate with B, B is almost sure that B also needs the IP address of A, or not only the IP address, also the Ethernet address of A. So each and every machine will be having a cache which will store the corresponding IP address and Ethernet address of the communicating devices. So in this case, B will also store the IP address and the Ethernet address of A. And when this packet reaches back here, A will also store the IP address. No, here is already having IP address. Here will also store the corresponding Ethernet address or MAC address of B. So instead of each machine maintains cache recently used mapping, ARP request is only or sent if the desired mapping is not in place. So next time if A wants to communicate with B, A will request for ARP request for only if the cache is not having the corresponding Ethernet address. So this is the working of address resolution protocol. So let me go to next slide. In next slide, you can see that so the another question which comes around is like, as you already see, A is the, B is the, C and D. So if the ARP request packet is going across all the devices, should C and D, so there is another E, F, G, H. So these are different hosts inside this particular network. You need to understand that ARP resolution protocol or ARP will only work inside a particular network. It does not cross the different routers. It belongs. It will only work inside a particular router. So what happens is, if A wants to send the ARP request, if A wants to send request, both C and D and B, those hosts which are part of the communication can store the corresponding IP address and Ethernet address of the communicated devices inside the particular cache. But since H, E, G, F they are not part of this communication, they not need to store the uh, what corresponding IP address and Ethernet address. If all these systems inside the network stores the Ethernet address and IP address inside the cache will be fully occupied, and we need to it will actually likely to have a waste of memory, because unless we need that particular machine, we don't need to store the particular IP address or Ethernet address. Then it is a full of waste of memory, and also we may need to flush the entries so that it can be used again. So only the communicated device needs to store the corresponding ARP request, IP address and Ethernet address inside the particular cache. So this is about intercontrol protocol. In the second part, we'll deals with uh, how. So we also mentioned about the solution as well in this topic. So how to deal with that all the machines can have a proper maintaining of the cache. So upon receipt of each and every ARP request from machine, so IP address is already available in the local ARP cache. So IP address is already. It will check for the corresponding cache. It will when each host receives the corresponding IP address, it will check in the local ARP cache and update the information for that entry. So this handles the case of machine whose address, if the particular machine, the Ethernet card is changed or the new machine is brought up, the ARP address with the old value will be all returned with the new value. So as I said earlier, only the device which are coming under the particular communication area will update the corresponding cache. And this is about the intercontrol protocol. In the next part, I will explain you about what is the structure of the ARP packet, and also about the RARP. Thank you.